Hello, everyone, and welcome to the first episode of Mechanical Drawing 202. Okay, so in this episode, we are going to look at spur gears. Now, what is a spur gear? Okay, spur gears are a type of cylindrical gear with shafts that are parallel and coplanar to each other. By the shafts, I mean the cylindrical members that are placed in these holes that you see here that rotate the spur gear, right? They are parallel to each other. So basically, these spur gears are used in various machinery to transmit movement or transmit force. Now, there are different types of spur gears, and the type of spur gear that we're going to look at specifically is the involute spur gear. Now, the reason why they call it an involute spur gear is due to the fact that an involute curve is used to design the gear, the tooth profile of the gear. By tooth profile, this curve here is referred to as the tooth profile of the gear, and it is an involute curve. All right, so these are two spur gears, and these two spur gears are of equal diameter, or equal size rather, and they are working together in a machinery. Now, the reason why I call this a cylinder, it does not look like a cylinder, but if you remove the teeth, you will suddenly realize that it's a cylinder. Now, look, if you look over here, you have two cylinders, a very long cylinder, because the height of the cylinder is very large as compared to the diameter, while here the height is considerably smaller than the diameter. So this type of cylinder that we're looking at here is this type, just with some teeth and a hole in the middle. Now, in order to draw a spur gear, there are a lot of things that we have to know about the spur gear, because at this level of mechanical drawing, we are going to be required to draw a spur gear, or draw two spur gears rather, that are meshing against each other, right? And by meshing, they are working together to transmit a force or transmit movement. Okay, so let's scroll down a bit further, and here I have two images of the same spur gear. Now, let's go over to the image that is more relatable. The image to the left. If you look, you are seeing some labelings that are showing you the different parts of the spur gear. Now, as you can see, this is a spur gear tooth, and this specific spur gear is designed to have 20 teeth. Now, there are different parts of the teeth. If you look at the top of the teeth, the top surface of the teeth, as you can see, is called the top land. The bottom surface of the space between two teeth is called the bottom land. Let's go over this side. If you notice, this is the side surface of the teeth, and the portion at the top is called the face of the tooth. The portion of the bottom is called the flank of the tooth. Now, let me show you how you know where the flank starts and stops, or the face starts and stops. This circle right here is the most fundamental circle of drawing a spur gear, and it is referred to as the pitch circle. Let me copy this pitch circle and paste it in the center of the spur gear over here. Now, if you notice, the pitch circle, it cuts the tooth here. So every part of the side surface above the tooth, above the pitch diameter on the tooth, is referred to as the face of the tooth, and the surface below the pitch circle is referred to as the flank of the tooth. I'm not going to remove this just yet. Let's look at some other parts. Now, you have the tooth thickness, and this tooth thickness is measured along the surface, or along the pitch circle, as you can see, and you have the space between the tooth. If you notice, if you're measuring the distance between two teeth, if you measure from the top, you'll have a greater distance than if you measure from the bottom. So that is why you have a specific spot that you will use to measure the space. And it is measured along the pitch circle. It's similar to the tooth thickness. Now, then you have the fillet radius, right? The fillet radius is the radius of the circle that will mesh the tooth profile with the base of the tooth, right? So it will not just have a sharp turn, it will have a radius, and that radius is called the fillet radius. Now, I forgot to label the tooth profile of this spur gear, and this is an involute tooth profile. So this curve is referred to as the tooth profile of the spur gear. And in future videos, you will be shown how to construct that. Let me see if I've missed out anything. Oh yes, there are two measurements. I'm going to copy this circle and this circle over here. Now, if you notice, there are two distances that are shown here. This distance, by the way, this circle is referred to as the Addendum Circle. This circle is referred to as the Addendum Circle. You may see other names that are used to refer to these circles. Like, for example, the Addendum Circle is also referred to as the root circle. The Addendum Circle is also referred to as the outside circle. Okay? So, the distance between the root circle and the pitch circle is referred to as the addendum, as you can see, and the distance between the pitch circle and the outside circle, or the addendum circle, is referred to as the addendum. So you have addendum and you have the addendum, and these distances they are critical in constructing the drawing of the spur gear. Let me see if I have everything. Yes, we looked at all these already. Oh, and by the way, these definitions will be placed in the description of this video. So when you are through watching the video, you can go ahead and copy the description and paste it in a blank document and save it for your reference later on. So now let's go across to this picture here, or this image here. This image is showing the same spur gear over here. Now over here, this is a very simple diagram. It's just showing you the parts and so forth. Oh, by the way, I missed out the face of the face width is basically the thickness of the spur gear, right? The thickness, which for the cylinder that is used to make the spur gear, it would be the height of the cylinder. But it's the thickness, is the distance between this face and the face around the back. Well, it's the face width. As you can see, this is the face of the tooth, and the distance of the face is right here. Now, let's look at this image here. This image is basically showing some parameters that are necessary in order to construct this spur gear. Now, let's look at it. This circle here, that will be, in a lot of cases, the first circle that you will draw. And this circle that I've selected is called the pitch circle, right? The pitch circle, this size will be determined by all the space that the spur gears that are going to be working together will fit in. So you determine this distance if it is not given to you. After determining the pitch circle, you have to determine the amount of teeth that you want in the spur gear. That is if it's not given to you already. Now, on this specific spur gear, there are 20 teeth, right? So the pitch circle diameter, which is the diameter of the pitch circle, and the number of teeth are critical parameters to note in order to construct this. All right, and as you can see, the addendum is shown here again. The addendum is shown. Okay, and as you can see again, you have the addendum circle, right? That is why the distance from the pitch circle to the addendum circle is referred to as the addendum. You have the addendum circle, and as you can see, this is the circle that cuts off the spur gear, because these involute curves would eventually meet and find and form a pointed edge. But the addendum circle shows where the teeth ends. All right. So you have the addendum circle, and then you also have the addendum circle. This is the base of the teeth. So the teeth, they don't go below the base, right? So you have the addendum circle and the addendum circle, and you have the addendum circle diameter, and that is right here. You have the addendum circle diameter, which is right here. Now, there are a lot of cases where you will not be given the addendum circle diameter and the addendum circle diameter. Those circle diameters are critical in constructing the spur gear. If you notice, there's another circle that is called the base circle. That circle you will eventually find, right? And in the next video, I'll explain further on how to find the base circle when we're actually going to show you how to construct the spur gear. So please observe the diagram again. I've already explained what the addendum is and the addendum. They are distances, and you can see the distance. One is between the pitch circle and the root circle. The other is between the pitch circle and the addendum circle, right? There's a way to achieve the base circle diameter, and that will be in a further video as I explained before. Now, after you have selected or assumed the number of teeth that you need, and you have selected a suitable pitch circle diameter, you need to now determine the distance, or the diameter rather, of the addendum circle and the addendum circle. Once you get those distances, you are now able to achieve the addendum and the addendum. Now, let's go over to these formulas. There are two critical formulas that are here that are necessary in order to draw the spur gear. The first are, I don't know if I should refer to this as a parameter, but this is the first formula. You need to find the diametral pitch of the spur gear, and you also need to find the module of the spur gear. And as you can see, this formula, a simple formula that only entails division, it is showing you how to get the diametral pitch, and it is also showing you how to get the module. Now, the diametral pitch is found by dividing the number of teeth, in this case it's 20, by the pitch diameter. Now, if we're supposed to find the diametral pitch for the specific spur gear that we're looking at, please observe the measurements here. You will realize that once you divide the number of teeth, which is 20, by the pitch diameter, you will end up with a diametral pitch of 0.5. Okay, or this is half. I think I may have calculated this incorrectly. Let me go ahead and correct that. So it's 0.2 actually. All right, so 0.2 is the diametral pitch right here, right? So the diametral pitch here is 0.2. Now, what is the purpose of finding the diametral pitch? Let me explain. Now, if you have two spur gears meshing together, once the sizes are different, they are going to need a different amount of teeth. For example, the larger spur gear will possess more teeth than the smaller spur gear. These spur gears that you are seeing here, they are of the same size. But you have instances where one spur gear is larger. Now, if you have a larger spur gear, let's say this was the larger spur gear and you needed a smaller spur gear, right? And let's say that the smaller, let me copy this formula. Let's say that the smaller spur gear, the diametral pitch, the diametral pitch for this smaller spur gear, let's say that it was 80, right? All right. So this is the diametral pitch over here for the larger spur gear. The number of teeth versus the pitch diameter. For the smaller spur gear, the diametral pitch is the pitch diameter is 80 and we don't know the number of teeth. Remember we said that it's supposed to be less. So whatever the diametral pitch is over here, it is supposed to be the same over here. So this is the, let me go again so I don't confuse you guys. This is the number of teeth for the larger spur gear. This is the pitch diameter for the larger spur gear. For the smaller spur gear, we are given a pitch diameter of 80 millimeters. In order to calculate the number of teeth needed for this spur gear to mesh, then you are going to use this equation here. Now, you are going to solve for x. So x would be, 20 divided by 100. Let me see if I have this formula right. Yes. So this would be 2. This would be 10. This would be 1. This would be 5. Right? And if you were supposed to bring the 80 over, all of a sudden the 80 would be divided by the 5. And 80 divided by 5, let me tell you what that is. 80 divided by 5. And the answer is 16. So let me put 16 here. 16, let me put what? The 20 here. And let me put the 100 here. Now, 16 divided by 80. If you check that out, you will get 0.2. That is the diametral pitch. If you divide the 20 by 100, you'll get 0.2, which is also the diametral pitch. So you realize that even though the two spur gears are of a different size and they have a different number of teeth, the diametral pitch for both are the same. For these now, they are the same size, so they'll have the same number of teeth. So you get the idea. So the diametral pitch is used to determine the number of teeth that you need for the second spur gear, because you would assume the first one. There are some other formulas that are used, and this is more advanced stuff, to calculate if the number of teeth is suitable and so forth. But for now, let's say that our assumption is correct and we have safely assumed the number of teeth. Then we can now find the pitch diameter of the other spur gear. If it is given, then you use it, and you can use this formula to determine the pitch, the number of teeth for the smaller spur gear. I'll explain that in the future video when I'm actually constructing the spur gear. Now, the next formula that is critical is the module formula. In order to find the module of the spur gear, if you notice these formulas are similar. One of them, you divide the number of teeth by the pitch diameter, while the module, you divide the pitch diameter by the number of teeth. For this specific spur gear, you are dividing 100, which is the pitch diameter, by the number of teeth, which is 20, and the answer is 5. So now the module is 5. Why would we need to find the module? Now, the module is used to determine the addendum circle diameter and the dedendum circle diameter. So now you know how to achieve this circle, which is the dedendum circle, and how to achieve this circle, which is the addendum circle. Now, normally, or most commonly, the addendum is given as m. So like how the module is 5. For example, by the way, this M stands for module. So the module is 5. So addendum equal 1 module. The addendum equals 1.25 modules. So this is modules. All right, here what? Let me write modules so you're not confused. I don't want you to think it's millimeters. So let me bring this over a bit. Okay. And since the addendum is equal to 1 module and the module for this spur gear is 5, then the addendum for this spur gear, will be 5. The addendum for this spur gear will be 1. Since the addendum is 1.25 modules and the module is 5, the addendum is now 6.25. All right, let's do that again. We calculate the module using this formula, and for the specific spur gear it is 100 because the pitch diameter here is 100, as you see it's pointing on the pitch circle, and that is divided by the number of teeth, which we know that it's 20 teeth, and you get 5. Now this module is used to determine the addendum. The addendum, there are various values that are used for the addendum and the addendum in terms of modules. Sometimes the addendum is 1 module, sometimes it's 1.35 module, it varies. But most often the addendum is 1 module and the addendum is 1.25 modules. And that's what I'm working with today. So the addendum is 5. And if you notice, I'm working unitless. I didn't specify what units we are working with, whether it was millimeters or so forth. So the addendum is 5, while the addendum is 6.25, based on what the addendum is normally is. If the addendum was 1.35 modules, we would have multiplied 5 by 1.35, and then the answer here would be different. So now if you look here, the addendum is 5, the addendum is actually 6.25, and I could have just put in brackets here. In this case, the addendum is 5, and the addendum is 6.25. Now, what does that mean for the addendum circle diameter? All right. So since the pitch circle is 100 millimeters in diameter, it would simply mean that the addendum circle would be 5 times 2 more than the pitch circle diameter. Why times 2? Now, this distance here, you have 5 here on this side, and you also have 5 on the other side. So this circle, the diameter of this circle, is actually larger than this circle by, if you notice here, 10. This is 100. This is this is 110. Now, what I basically did here, I drew the pitch circle first, and I used the offset command and offset the addendum, and then I used it again to offset the addendum below. Now, if we are working with the radius, from here to the pitch circle would be 50, since the diameter is 100. From here to here would be minus the addendum. From here, from the pitch circle to the top here, would be adding the addendum. And notice we're talking about the radius. Now, if we are working with the diameter, everything will be doubled. So that is why, in order to get the diameter of the addendum circle, we add 5 plus 2. And to get the diameter of the addendum circle, it is 12. Whatever this is, we multiply it by 2, then minus it from the pitch circle diameter. Simple math will show you why that is the case. All right, so let me see if I've covered everything. So we have covered the definitions here, or the descriptions or the labelings here. And as I said before, these will be posted in the group description. We have also covered the different circles that are needed to construct the spur gear. We have the pitch circle. This is the first that is normally given. Notice I said normally. I've seen a lot of videos where persons started off even with the root circle. Alright, but we're starting off here with the pitch circle and the number of teeth. And once you use those, it will help you to determine the addendum circle and the dedendum circle by use of this formula right here, the module formula. And it will also help you to determine the diametral pitch. And as I was explaining before, the diametral pitch helps you to determine the number of teeth that will be required for a second spur gear that will be meshing with this spur gear in any machine that it is being used for. So basically that's it for this lesson. Please stay tuned for the next lesson. In the next lesson, you will hear some terms such as pitch point, pressure line, pressure angle, clearance circle. All of those are better explained. Those terms that I've just mentioned are better explained when you are seeing two spur gears meshing together here. And a lot of those parameters are needed in order to draw two spur gears together, right? So stick around for the next video. Thanks for watching. If there are any questions that you have, please drop it in the comments so that I can answer the question. If there's anything that I think I didn't explain as clearly, please drop it in the comments so that I can do an update video to clarify whatever concerns that you have. Okay, please like, share, and subscribe, and thanks for watching. Have a good day.